Hey everybody, it's Mrs. Hageman. I'm going to take you through notes 4.3, rotations on a coordinate grid. Okay. In this activity, you'll explore some ideas about rotations. A rotation is a kind of transformation, like a turn, that we make to a shape or image. What are some things that you notice about the graph to the left? What direction is it turning in relation to a clock? So I will say that the orange or gold image is turning. That would be counterclockwise, right? Something to point out, the green triangle is the pre-image because it's not moving, and that would be the beginning point. Okay, something else you can say here is that the triangles are the same size, and we're not changing the shape. Because in transformations, which are translations, reflections, rotations, we have to maintain the same size shape, okay? Something else to notice is that it's rotating around the origin, which is 0, 0. And these are not all things that you may notice right away. The one thing you want to notice on your own is that it's rotating counterclockwise or turning. All right, so on slide 2, this is just a way for you to explore which direction is clockwise and counterclockwise. So you're not going to draw hands on the clock. Okay. Rotation happens in one of two directions on a coordinate grid, but we do want to use a clock to help us. So clockwise means in the same direction that the hands of a clock turn. So this one is clockwise over here. So starting at 12 o'clock, we're going to draw a curved arrow to show the direction that the hands would move. And we got to see where your arrow ends. So I'm going to start here. Clockwise goes in the order of the numbers. So 1, 2, 3, 4, 5, etc., all the way back to 12. So that's clockwise. And then counterclockwise is opposite that direction, going backwards. So 12, 11, 10, 9, 8, 7, 6, 5, etc. And what's difficult about geometry is that the coordinate grid is not set up with quadrants that go clockwise. They go counterclockwise. So that's why it's very important to know which one we're talking about. Slide 3. A pre-image is a shape before it is rotated. The green dotted shape is a pre-image. An image is the shape after it is rotated. The gold shape or the orange shape, the triangle, is an image of the green pre-image. Okay, we want to draw a curved arrow with the sketch tool to show how the pre-image points could rotate to the image point. So the direction of the arrow matters. So let's point out here that the pre-image is not in quadrant 1, it is in quadrant 2. Okay, when we are younger, we learn positive numbers first. So we learn distance on a ruler, and then we can measure height of things. So positive, positive is quadrant 1. Quadrant 2, which is counterclockwise, is leftward, and then quadrant 3 is down here, which we're not using for this problem. So you can see that the way the coordinate grid is set up actually has a natural counterclockwise movement to it. 1 to 2 to 3 to 4 and back to 1. So the coordinate grid is counterclockwise. And so if something's moving clockwise, it's going back, or it's losing a quadrant. So here we're going from quadrant 2 as the green, and we're going back to quadrant 1. So this is a 90-degree rotation, okay, which we'll see in the next couple slides. And so you can also connect your points together. So I can directly do that here. So -2 and 2 become 2, 2, and then the point -1, 4 gets rotated over here, and then point -3, 3 gets rotated over there. So all we needed to do here was draw a curved arrow. So this is an exploration for you to do at your own pace, and then check this video for your answers. So did the green triangle rotate clockwise or counterclockwise to create the gold image? Remember our arrows. So we started in quadrant 2, not quadrant 1, and we rotated backwards. So the ordered the coordinate grid goes 1, 2, 3, 4, which is counterclockwise. So if we're going from 2 to 1, that would be a clockwise movement. Okay. So we're going from, I would say, I don't know, 11 o'clock, 10 o'clock, 9 o'clock over here to like 1, 2, or 3 o'clock. So that would be a clockwise movement, even though the coordinate grid has a counterclockwise label to it. All right, so very important to understand the difference. Clockwise is the arrow you see. The coordinate grid itself is labeled counterclockwise, starting at the 1 and then going the other way. So that's why these rotations are sometimes going to be confusing and the most difficult, because we have to notify the difference between clockwise and counterclockwise. All right, so now we have an exploration here. So you can pause this video and play around with the slider tool. So we have counterclockwise. This is by default which way we would rotate. If it doesn't tell you which way to go, you would go counterclockwise. So shapes can be rotated 0 all the way to 360. It would be back on itself, okay? The pre-image is in blue, and that's quadrant 2. Okay, that's why we labeled the quadrants in the previous slides. If you're not sure of the quadrants, make sure you go back to review them. Okay, so we're in quadrant 2. So if we rotate this 90 degrees, which by default is the way we rotate on the coordinate grid, that's called counterclockwise. So 90 degrees would put us in quadrant 3 because we were just in 2. If I rotate 180, now I've done 2 turns. This is 1 turn. So 180 counterclockwise is quadrant 4 because we were in 2. So 2, 3, 4. And that was 2 turns or 2 changes in the quadrants. And then if I rotate 270 counterclockwise, that's the default. And it's not going to be exact with your slider. It'll be approximate. That's going to be 270 degrees. So now we're going to be in quadrant 1. That was 3 turns. And what you'll notice is 273 turns is the same as 90 clockwise. I do want to point that out for you all that are seeing that. So 270 counter is the same as 90 clockwise. That is something that you can understand, although it didn't ask it in this question. And then which rotation results in the same pre-image and image? 360. Goes back to the beginning. And that was quadrant 2. So that's the default. So if it tells you to rotate something 90, 180, 270, or we won't do 360, we're just showing you that. You're always going to go counterclockwise unless it tells you to go clockwise. Slide 6. So now we're going sort of right in the right direction, although it's hard to say right or left because then when we get down here, it looks like it's going left. So let's not use right or left. Let's use clockwise, counterclockwise. So this is clockwise, okay? So 90 clockwise was the same, sort of the same idea of 270 counter in the last one, okay? So 270 counterclockwise, which is from 2 to 1, sort of kind of looks like if we do 90 clockwise. Okay, there are these relationships that we can develop here. So which rotation results? Same thing. So we started in quadrant 1. So if we go 90 clockwise, we're going to be in quadrant 1. So we're losing a quadrant here. Do 180 clockwise, we're going to be in quadrant 2. .270 clockwise, we are in quadrant. I am very sorry. It's not 2, it's 4. Some of you caught my mistake there. 270 is going to put us in quadrant 3. If I go back to the beginning, be in quadrant 2. Make sure you use your quadrants one at a time. So I kind of knew quadrant 4 was wrong because it started in quadrant 2. And then I do want to point out that 270 clockwise, which is where it's at here, okay, that is the same as 90 counterclockwise. So those are going to be some ideas that we'll see in the next couple slides. And then last one before we do part 2 of a video, use the sketch tool to help you visualize how the puzzle piece will rotate. Which of the 4 puzzle piece images is the result of a 270 degree counterclockwise, although it doesn't have to say counterclockwise. If you're not told which way, by default you go counterclockwise, so that does or does not have to be there, okay? The only time you go clockwise is when it tells you. So counterclockwise, rotation of the pre-image. So here's the puzzle piece, okay? I would suggest eliminating answers. So we're going to eliminate A, because you can say A and the original puzzle piece look the same. So this would actually be a 360 rotation because it's back to the beginning. So do not pick A. And then it appears that turning this once, which is 90, okay, is going to put one of these jutted out pieces of the puzzle on the right, and then this one's going to be at the top. Okay, so we need to find a puzzle piece to eliminate where one of them is sticking out on the left and the top. Okay, so this one, letter C, has the left sticking out and the top, which would be turning that puzzle piece once. So we want to eliminate that one because that would be 90 degrees counterclockwise. So then we're left with 2. Okay, so a 270 turn counterclockwise is 3 turns, or you could just go 90 the other direction. Okay, so remember 270 counter, that's also the same as 90 clockwise, and I'll just do CW. So if you're struggling with turning something 3 times, just turn it once. Okay, so 90 clockwise is the same as 270 counter. Okay, if you can't understand that yet, that might be something that you can understand at the end of the week. So that means that this one is coming down here and that one is coming to the right. So we have our gaps on the left and the top, and then we have one sticking out on the bottom and to the right. So letter B is going to be your correct answer here. So that was 3 turns counterclockwise. Some of you can see that it's 1 turn clockwise, which was 90, and it didn't tell us that, but we can, some of us can see that similarity there. All right, and then we can eliminate D. We didn't really touch on that, but you could have gotten the right answer by eliminating D as well, because we can see that a 180, okay, it kind of looks like a reflection, but it just turns each piece twice. So the top would then become the bottom, okay, and the right would then become the left for our 180. So that's how we could eliminate D. Top becomes the bottom, left becomes the right for a 180 degree rotation. Okay, if you could see that as well. So the answer to 7 is letter B, and then stay tuned to the second video for the rest of the slides.